You are watching for the greater good.
Hello guys and welcome to our channel for the greater good. Today we'll be studying link structures. A linked list is a linear collection of data elements whose order is not given by their physical placement in memory. Instead, each element points to the next element. Linked list allows data from multiple data types, and it also allows efficient insertion and removal without relocalizing or relocationing of data, as contiguity of data in memory is not necessary in linked lists. Singly linked list. A singly linked list is a data structure of node which together represents a sequence. Each node contains a data and a reference to the next node. How to create a node? A node contains two parts. The first one is data and the second one is pointer to the next node. By default, a node points towards none, and keep this in mind that when a node points towards none, it means that this is the last node of the link structure. How to make a singly linked list? First, we create an object A and we give 10 in its argument. 10 will be the data value of A, and by default it will point towards X. But we don't want A to be our last node. We want to add another node after A, and that node is B. So we'll change A.next is equals to B. Then we'll define B, and the data value of B will be 20, and B will be pointing towards none. That means B is the last node of the link structure. Okay, so this is our singly linked list. Now we want to insert in this list after this node B. So first we'll check whether this node B exists or not. Now n is the new node which we will be creating, and we have given the argument 9 for the value of this new node. Previously B was the last node of the singly linked list, but now n will be the last node of the singly linked list, and as we have learned earlier that the last node points to none, and there cannot be two last nodes in a singly linked list, so n will be pointing towards none and B will no longer point towards none. Instead, it will be pointing towards this new node n. Now we will learn how to traverse a singly linked list. Okay, so this is our singly linked list. Keep this in mind that we can traverse the singly linked list from any node given, but if we want to traverse the complete singly linked list, we need the head node. First, we will check if A exists or not. Here A is equals to self. While A is not none, we will print the data of A. In the first iteration, the data of A will be 10. Then A will be equal to A.next. So that means that A will become the node that A was previously pointing to. In the next iteration, the data of A will be 20, and in the next iteration data of A will be 9, and here the while loop breaks because A.next will be none. So this is how we traverse a singly linked list. Now we learn how to delete in a singly linked list. This delete function deletes the node next to the self node, and in this case we want to delete the node next to the head node, so this node containing 20 will be deleted. First we'll check whether this head node is valid or not, and we have to return the node which we delete at the end of the function. So we create a variable called x. If self.next is none, there is no node to be deleted, so this function will return none in that case. If there is a self.next exists, that self.next will be equal to temp. Temp is the name of the node containing which or self node is pointing to, and x will be the data of that temp node. To remove a node from the linked list, we have to modify the node before it, as if the node before it is not pointing towards that node, it will no longer exist in the link structure. So as head was previously pointing towards temp, we change self.next, and now head points towards temp.next, the node that temp was pointing towards. So as you can see, we have efficiently removed temp from the linked list. We will return x, that is the data for the node we have removed. This is the last phase of our video. We learn how to search in a single linked list. We have to give the target element in the argument of the search function. We can start searching the link structure from any node, but to access the whole link structure, we need to start from the head node. First, we'll check whether this head node exists or not. Then, if self.data is equals to target, we won't be going into the while loop. We'll just return a list. The 0th index of that list will indicate whether the search is successful or not. The first index will be containing the address of the node before or target node, and the second element contains the address of the target node. B is the node which A is pointing to. The conditions of the while loop are that B is not none and B.data is not equals to target. Now we'll go through the while loop. First, A is the head node and B is the node with data value 20. In the second iteration, A becomes the node with 20 and B becomes the node with data value 9. As B.data is equals to target, we won't iterate any further. We will return true, A, B. Thank you for watching our video, guys, and stay tuned for our next video.